Okay, let's get started, guys. I hope everyone can see my screen now. I take it. If I hope my voice is also clear. All of you can hear me.
Yeah.
Okay. Good. So quick recap, guys, what we learned last time. I have two slides for you. Last time we have seen that there are five, different types of machine learning algorithm and under which circumstances we should use them. So very first one is the classification algorithm. If you would like to make a choice whether it's A or B, you should go for classification. If you would like to evaluate weirdness of the data, then you go for anomaly detection algorithm. We had like an example of a credit card of fraud for anomaly detection. If it is like how much or how many, what will be the price of the apartment, then you should go for regression algorithm. If you would like to know how the data is organized, then clustering. And if you would like to evaluate what should be the next step, the reinforcement learning. Again, we talked about chase-like artificial games for artificial intelligence games for reinforcement learning. Therefore, with this machine learning tree, so a higher level machine learning has got three different branches. Very first one is supervised learning, unsupervised learning, and reinforcement learning. So as part of supervised learning, we have classification related algorithm, which serves for identity, fraud detection, and also it can help us for image classification. We have regression algorithm, which helps us to predict the population growth and also do the marketing forecasting. Otherwise, unsupervised learning has got clustering and dimensionality reduction, wherein clustering helps us for targeted marketing, and dimensionality reduction it helps for big data visualization. Otherwise, we have reinforcement learning, and game like chess goes for reinforcement learning. This is what we discussed last time. For today's session, I have got almost 68 slides and only 45 minutes, so I will move a little bit fast today. But let's gone through with the regression. If the data is organized like this, then a simple linear regression model will help us a lot, and we typically go with the mathematical function that is y equals to b0 plus b1x. That's the simple linear regression model. This is what we have seen. Afterwards, in case if we have more coefficient, more than one coefficient, then we should go for multiple linear regression model. And in case if you have the curve into data, then it becomes polynomial regression, and the typical format is typical mathematical formula for that is y equals to b0 plus b1 x1 plus b2 x1 square. So that's x1 square gives the curve to this graph, and that's why we call it as polynomial regression. This is what we have seen so far. So the right hand side graph, okay, if your data is aligned like this, then we know that it's a simple linear regression model. But what if you have data this particular fashion, what we should do then? So if that's the case, then logistic regression comes into the picture. For logistic regression, in R we have a particular function named GLM, and this one line of code can do all the magic for you. Where you just apply the GLM, you create a formula, and then you are done. So one line of code and your classifier is ready. So it is very simple in R to create the logistic regression or other model. But typically what happens that once your model is available, it gives you some result, and afterwards you should be able to identify whether my results are good or bad, or what kind of message it is giving it to us. For that, we have two different factors. One is R squared and adjusted R square. Time is less. I had those slides with me, but somehow I deleted them so that I can focus more onto the neural network and how human brain works. So I will put in more time for those things. So I will quickly move forward from here. But here I just wanted to tell you that if your data is parallel to each other, then you should go forward for logistic regression. Let's say that you have data distributed like this. This plus sign is one category of the data, and this red plus sign is another category of data. How you will identify if there is one more plus sign assigned to this data? How you will identify whether the color for that particular data is green or red? So when I say green, it means category 2, and when I say red, it is category 1. So in machine learning, it's all about prediction. We have lots and lots of data in machine learning in background, but we would like to do the prediction for upcoming data. So here, what we wanted to predict, whether this new plus sign or the new data point would fall under category 1 or category 2. We have k nearest neighbor algorithm in machine learning, and what actually it does, once you apply the k nearest neighbor algorithm onto this particular data point, what it will do, it will tell you whether the color of that data is green or red, or whether it belongs to category 1 or category 2. So this is the result once you apply kn and k nearest neighbor. But how exactly it does that? So before we get into that, first we need to understand the Euclidean distance, and all of us have gone through with this particular formula during our high schooling. So it is like x2 minus x1 square plus y2 minus y1 square, and then take a square root. So this is the formula. We call it as Euclidean distance, which is getting utilized into k nearest neighbor. So there are 4 different steps. I will quickly walk you through with how exactly those 4 steps work. So let's say that you have category 1 wherein 7 to 8 data points are there, and you have category 2 with the 6 to 7 data, okay? And you inject one more data point over here, and now you would like to predict whether it falls under category 1 or category 2. How we are going to do it? There are 4 steps. What we're going to do? First, we will identify the 5 neighbors of this particular data point. So this becomes the very first neighbor, this is the second, this is the third one, this is the fourth one, and this is the fifth one. And out of which we take a sum of a maximum number of data points which are near to this particular data. So this one becomes 2, this becomes 3, and which one is closer to this one? It is this particular category. So it's very easy for us to identify that this particular plus sign or this data point will fall to category 1. It is as simple as that. I will again repeat, we wanted to predict whether this particular data point belongs to category 1 or category 2. First, we'll identify 5 nearest neighbor of this data point, and that's why we call it as k nearest neighbor. K means the number, nn means nearest neighbor. So we identify that, okay, these are the 3 data points which are near to this data point, and these are the 2 data points which are quite closer to this one. And we take a sum saying that, okay, these 3 data points are quite near to this one, and hence it should belong to category 1. Going to do, guys, I am going to cover this algorithm at a very higher level so that you understand how exactly machine learning algorithm works. Understand that it is 4 o'clock and still you're dialing in, and I really appreciate that. So quickly move forward. So after k nearest neighbor in machine learning, we have another very important algorithm which is called as SVM, and it is support vector machine. Let's say that you have data points distributed like this. How we can separate these data points? We can have a vertical line like this. We can have multiple line like this, and also we can have one horizontal line like this. So one is the best fitted one. So if these kind of questions are being asked to a machine, then we should apply SVM, that is support vector machine algorithm. And exactly this SVM works, it's pretty easy. And we need not to do much coding for that. There are already algorithms written. There are already methods available. We just need to use those methods into our code, and then we are done. So what it does that, it first takes one particular line, and then it checks the support vectors. Okay, support vectors means the equal distance from this line to the boundary of this data points. So green line, in the green data points, this one is the one which is very closer to this line, and this red marked one is the one which is very closer to this line, and that's why we call it as support vector. And then we identify that, okay, whatever falls below to this red line will get into the negative hyperplane, and that's why we'll call it as category 1 or a red marked data point. Whatever is above to this particular line, it becomes positive hyperplane, and then we will call it as green data point. If you are not able to get through this, I have a very good example for SVM, and then it will be very, very clear to all of you. So one thing which we all need to know about SVM is that this is different kind of algorithm. There are so many algorithms in machine learning, but SVM is literally different. Say we take one example. We have a basket of oranges and apples. Okay, and now we would like to identify which one is apple and which one is orange. Or if you would like to put in one more fruit over there, and if you would like to identify whether it is orange or an apple, then in this kind of scenario, SVM is pretty much helpful. There are so many algorithms in machine learning. So what other classification algorithm does that, first they learn about apple and oranges. They learn about their characteristics, and then they apply those characteristics or rules onto the new fruit which is put up onto that basket. But SVM is a bit different. Works on to support vector, and it literally identifies first the orange which looks like an apple. It learns about it, and then it identifies the apple which looks like orange. It learns about it, and afterwards it's the comparison. We'll show it into the next slide. So let's say you have got this many apples over here marked in red, and you have this many oranges marked in green. Now you have to identify that if we put up a new fruit over there, whether it will be apple or orange. So it has got three steps. What it does, it try to identify the apple which like an orange. Can you say this? This is an apple, but it looks like an orange. Okay, that is step number 1. And say that this is the apple which looks like an orange, and that's why we mark it down. The second, identify the orange which looks like an apple. Let's say that this is the orange which typically looks like an apple, and this is that data point. And we take the equal distance between this data point, and we draw a line so that we get the positive hyperplane and the negative hyperplane. It is typically done. Now you have the classification. Whatever falls below this particular line will be apple. Whatever goes above to this line will be orange. So this is how SVM support vector machine works. This one is, let's say that your data is distributed like this. You can do the classification for your data points. If you have data distributed in this particular manner, then yes, you can draw a line in between, and then it becomes linearly separable. But this kind of data is not linearly separable. What we should do then? In machine learning, we have Gaussian RBF kernel. Don't go ahead with this mathematical formula. It will be all there embedded into the algorithm. We just need to know the method so that we can use it. So what we typically do, first we identify the center point of data point, and then we measure the difference or the distance between that center point to the data point. And if it is if it is closer to 1, then it becomes category 1, otherwise it becomes category 2. And for that we have Gaussian RBF kernel function which does that for us. So this is the 2D lookout. Otherwise, if you would like to see 3D, it looks like this. So what we have to identify over here, if we introduce a new data point, the color of that would be green or red. So this is how exactly it is done. For that we apply RBF kernel function, and then it will identify. Likewise, if you have data points segregated like this, in that case we apply two different kernel functions, and then we take an average of it, and then we can certainly identify whether the new data point would be green or red. Likewise, in machine learning we have three different kinds of kernel function. Very first one is Gaussian kernel, second one is sigmoid, and the third one is polynomial kernel. I'm going to skip this Bayes theorem for now because I really wanted to spend more time onto deep learning today. But I have just spent 10 minutes so far. Is there any questions so far? Okay, no. So my plan is to wrap up this call in next 20 to 25 minutes because it is Friday. I understand everybody would like to leave for the day, and still I really don't want to hold up you guys for long. But before we do so, I really wanted to spend enough time on to deep learning. So deep learning is again one part of machine learning which is hitting market like anything. Entire world is mad about deep learning. Whatever we see happening in Google, Microsoft, and all big companies, everything is deep learning. So what exactly is deep learning? It's a field of machine learning, and it is typically based on the way human brain works. We'll see it in next slide, how human brain works. So if you see this graph, guys, you will understand when exactly deep learning makes sense. So if you have lots and lots of data, then only deep learning makes sense. But if you have average amount of data, then any older algorithm, right, like classification and all those algorithms which we have seen so far, like SVM and nearest neighbor, they are sufficient. But if you have lots and lots of data, then we should go forward with deep learning. Okay, guys, we understand deep learning. We literally need to understand the processing power and memory capacity. So in 1956, actually, 5 MB of data used to cost $2,500, just for rental on for 1 month. That was the story in 1956. But in 1980, 10 megabyte of data, it cost was $3,500. But nowadays, in 2017, we get almost 150 or 256 GB just for $150. So this is exactly we are now. And this deep learning, it requires actually lot and lots of data. And deep learning, this concept is not new. It is in existence from 1960. But the thing is, it requires lot and lots of data. It requires processing power. It requires memory capacity, and that's why deep learning is hitting the market nowadays. Next one is DNA storage. So the next fear for storage is DNA. Currently, DNA storage is still in progress. As of now, if you would like to synthesize, 2 MB of data into DNA, it used to cost $7,000. And just to read the data, it cost $2,000. So to read and write the data of 2 MB of size, it's cost $9,000 nowadays. But scientists are they are still looking into DNA storage, and here is the projection. So once we have DNA storage up and ready, then 1 gram of DNA can hold up to 1 billion terabytes of data. And with that statistics, entire world's data can be pretty much captured into 1 kg of DNA. This is where entire world is heading about now. You see this graph. Initially, we started with the very low processor capacity. Nowadays, we are into the phase wherein a processor can mimic a mouse brain, and we are into 2017 currently. And the projection is in next 5 years, our processor will surpass the capacity of human brain. And after 25 years from now, processor will surpass the brain power capacity of all human beings in the world. So this exactly we are heading, and that's why this deep learning is coming into the picture nowadays. So guys, deep learning is all about. This is how deep learning looks like. So in deep learning, we used to have typical three different phases, or layers. Very first layer being the input layer, and the second layer is hidden layer, and the third one is output layer. We'll explore it in a couple of next slides now. If you see Geoffrey Hinton, he is the godfather of deep learning. He started researching, deep learning in 1980s. Currently, this guy is working for Google, and still there. He's working with Google and doing, great job over there. There are so many things this guy is still doing, and he is known as the godfather of deep learning. So, what deep learning is all about? So, the way human brain works, we get mimicked into the machine, and this is what deep learning is all about. So before we get into the details of deep learning, first we need to understand how exactly human brain works. Once we understand that, then it would be very easy to understand deep learning. So let's get into human brain first. And human brain, what we have got more than 100 billions of neurons. So billions and billions of neurons are there in a human brain, and each neuron has got body, tail, and branches, and each and every neuron is connected with thousands of its neighbor neurons. So if you try to see human brain inside the human brain through microscope, this is what you will see. There are billions and billions of neuron. Each and every neuron has got three different parts: the body, tail, and branches. If you take a microscope and try to see inside human brain, this is how it would look like. And each part of human brain exactly it is. It is the back portion of our human brain, which is called as cerebellum, and it has got billions and billions of neurons. How a human brain works? Actually, it gets the data from nose, eyes, ears, and human touch, and we call it as input layer. The second one is, it has got billions and billions of neuron, and we call it as hidden layer, and finally we get the output. I have other slides with me which will explain how exactly it works. So let's say that we have got three neurons, and each and every neuron has got some input value. So let's say that input value 1 is given to neuron 1, input value 2 is for neuron 2, and likewise we have input value 3 for the number 3. And these three neurons make it as one input layer. We have one hidden layer with 4 neurons, and finally it gives us the output. So how exactly it works? Each and every neuron is getting connected with 4 different neurons. So this is the neuron number 1. It gets the input and it passes it to the 4 different neurons. Likewise, input value 2 will be passed by this particular neuron to all these remaining 4 neurons. Likewise, input value 3 will be passed by this neuron to other 4 neurons. The neurons will receive the signal from these 3 neurons. It will process them, and then it will provide the output to the final neuron. Question, why we call it as learning? Where exactly is the deepness? There it is. So here what we used to do in artificial neural network is we used to have hundreds and thousands of hidden layer, each one getting connected with all other layers. It processes the data, pass it back to the next hidden layer. That hidden layer will pick up the input value, process it, and then it will pass it back to the next one. I think you might have got a fair enough idea about how exactly deep learning works, but in coming slides, I'm going to cover how exactly neuron works, what is the activation function, how neural network works, and how neural network learns from itself, and the back propagation. Any other before I move on to the next one? So if you see how a neuron looks like, this is how it is, So Spanish neuroscientist Santiago Ramon, he came up with this drawing in 1899. He has looked into the human brain through microscope, and this is what he has drawn in 1899. So every neuron has got three different branches, three different parts. Very first one is body, second one is the branch, and the third one is axon, which we are going to see into the coming slide.
Neurologist or the Scrum Infosys IT employee?
No, Bhargav, just trying to be something.
Good. Yeah, good. Yeah, thanks.
Yeah, so if you see this, this is a neuron actually, and it has got three different things. One is the neuron itself. The second one is dendroid. These are the branches which used to receive the signal, and the third one is axon. So this tail, we call it as axon. And how exactly these three things works together. So you see that as I told you guys, a human brain has got billions and billions of neurons. They all work together. One particular neuron doesn't make any sense. It doesn't do anything which is of any significance. But it's like an ant. One ant can't do anything, can't do much. But if there are millions of ants, yes, together they can do magic. So it's like this in this pictorial format. This is the neuron. It has got dendroids and it has got axon. This axon is getting connected with the other neuron. This is the dendroid which receives the signal, and then it processes the data, it passes it back to axon, and this axon is getting connected with another neuron, and that neuron will process the data and will pass it back to the next one. So likewise, all the billions and billions of neurons are getting connected with each other. When we say that they are getting connected with each other, there is no physical contact in between them. They just pass the electric signal from one neuron to another neuron, and we call that particular layer as synapses. Still, the mystery for scientists, if one neuron is not getting connected to another neuron, how exactly it is able to pass the signal, but this is how exactly it works. One neuron is capable enough to pass the signal to the next neuron. Are the receiver, and axon works as the transmitter. We'll go through with a very quick example. Let's say we have got M neuron, X1, X2, and XM, and these are the yellow marked neurons which takes the input signal. They take it and then push it back to the next neuron, which processes it, and then it provides the output signal. So this is how artificial neural network typically works. We'll see a good example just after this one. So say that X1, X2, and XM, these are the M independent variable. Okay, and together they pass it back to the green mod neuron, and finally it provides the output value. So now in this particular case, output value can be continuous. For example, price related thing, it could be binary like yes or no, or it can be a categorical variable as well. Instead of one output, one neuron can come up with multiple output value as well. For example, here in this case, this green mod neuron is capable to create three different output values, which is getting passed to the second list of neuron, which is there in the hidden layer. And how typically this neuron processes the data. Let's say that we have X1, X2, and XM neuron. Each has got its own input value. So each neuron will apply weight onto itself. So that X1 has got weight W1, X2 has got weight W2, likewise XM has got weight WM. How typically neural network learns? It learns it from its own weight. So initially it gives the average weight to each and every neuron, and afterwards it cross verify whether that weight was right or wrong. If it is wrong, then it reapplies the new weight and then again checks it. We'll see how exactly it happens. So let's say that X1, X2, and XM has got weight W1, W2, and W1. The first step is take the sum of all those things. We are going to multiply X1 with W1, X2 with W2, likewise XM with WM. We do that, and then we take the sum of it. And next step, we apply a particular activation function onto it. So this is marked here as a sigma. We'll see there are four different types of activation function. What exactly activation function is all about, what exactly it does, we'll see it in upcoming slide. But as of now, just remember that X1 has got weight W1, X2 got W2, likewise XM has got WM weight. We multiply it and then we apply a sigma, that is activation function, and then finally it predicts the value Y. Now we'll see what the activation functions are all about. So the one particular activation called as a threshold function. What it does, it's very rigid. If x is greater than or equal to 0, then its value is 1. But in case if signal is negative, that is x is less than 0, then it marks is at 0. So threshold function is very, very rigid. It gives the output either as yes or no. But we have another activation function number 2, that is sigmoid. So for that, it calculates like 1 divided by 1 plus e raised to power minus x. So it applies minus x onto e and then adds 1 and then divided by 1. So this is how the sigmoid function works, and it's pretty smooth. If you see it over here, it is very rigid. It gives you data either 1 or 0, but sigmoid is very smooth, and that's why it is typically used nowadays. But we have another one, that is a rectifier activation function. What it does, up to 0, it is straight. The result is always 0, and it is very flat. And afterwards, it gradually moves on. It becomes 0.1, 0.2, 0.3, and it goes up to 1. This kind of rectifier activation function is very, very popular in artificial neural network nowadays, and most of the algorithms are using rectifier only. Hyperbolic tangent also, its mathematical function is a bit complex, and that's why rectifier is the one which is getting utilized nowadays very, very frequently. So we have seen how exactly artificial neural network works. I will just quickly revise it. What it does, it applies weight onto each and every neuron, and then multiplies it, takes the sum of it, and then apply one particular activation function, and then provides output value. We will example of a housing price so that it is very clear to all of you. Let's say that we have input layer. Very first first neuron is getting input as area feet into the feet unit. The second neuron is all about number of bedrooms. The third one is distance from the city, and the fourth one is all about age of that particular property. What we are going to do, we are going to predict the property pricing. So input layer has got this input layer has got four different neurons. Very first one is for area, second one is for bedrooms, third one is for distance to the city, and the fourth one is all about age of that particular property. And the output layer marked in red, and call it as Y. There is no hidden layer at all. How we are going to work onto it, how we are going to calculate the price, we just multiply W1 with X1, W2 with X2, W3 with X3, and W4 with X4. We just take the sum and that becomes our price. It is as simple as that. So in this particular example, there is absolutely no hidden layer. We have just got input layer and output layer. But that we introduce one hidden layer into it. Include a hidden layer because this hidden layer gives extra power to this algorithm, and then it goes for the perfection. And that's why we used to have more than 10, 20 or 50 hidden layer into a neural network. More hidden layer you have, better the accuracy would be. That's the thumb rule for neural network. Let's say that very first neuron is X1, which represents area, and the second one is bedroom, and the third one is distance to the city. So let's try to understand that why this particular neuron is feeding another neuron and not to this one. So if you see this X1, this neuron is feeding to this particular neuron and not to this one. Likewise, this distance is again fitting to this particular neuron, and how that is possible. What we've seen over here, that this area and distance to the city is feeding this particular neuron, and under what circumstances it is possible. Let's say that you are interested to go out of the city and you are interested into the bigger home, and in that particular case, what makes a difference to this particular neuron is distance from the city and the area, not the number of bedroom and the age. Why? Because the more further you go ahead from the city, you will get more and more areas for your property. This is how it works. We can summarize it that for this particular neuron, area and distance is of importance. Bedroom and age is not of any importance for this particular neuron. Likewise, for this particular neuron, area, bedroom, and age makes a lot of difference. And under what circumstances, this thing can come up. Let's say that you have a very big family, you have your parents with you, you have a couple of kids, and really you are interested into the bigger home with more and more bedroom, and also you would like to see that it's pretty new instead of getting into the second home. And let's say that this particular neuron is interested into these three things. That this neuron is connected, the X4 neuron is connected with this neuron and this neuron and this one. So under what circumstances it is possible? Let's say that your property is 100 plus years old and it's a historic building, and there are people who are interested into historic building, and they can say that yes, my building is 100 plus years old and it has got some historical significance. So with that condition, we can mark it as these three neurons are interested only into the age, not onto other thing. So likewise, there are different conditions. Each neuron is passing the signal to another neuron. All these neurons process those details and data and then pass it back to the final one, that is this red mark of Y neuron, which is the final price. So any questions so far, guys? Before I move on to the next one. So how typically neural network works? Let that we have one machine learning algorithm and we wanted to identify cat and cat or dog as in dog. How the traditional algorithm will work, The traditional algorithm, first it will try to learn about cat or dog. And it will come up with the rule saying that, okay, if the ears are pointy, then it should be cat. If the eyes are small, then it is cat. If the size is quite big, then it should be dog. This is how traditional algorithm works. But in neural network, what we do, we feed the pictures to the neural network. It goes ahead, process those pictures and try to learn about dog and cat first. It learns the characteristics of dog and cat. And afterwards, if we try to cross verify if the new animal will be dog or cat, then it becomes very easy. This is the basic difference between all other algorithm and artificial neural network. We'll see this example very quickly. What we have seen so far is we have got x1, x2 and xm neuron. Each neuron has got weight. It calculates the summation and multiplication of all these things and then applies the activation function on top of that, and it predicts the value. So we should be knowing what is the actual value and what is the output value, and then we come up with the cost function. So the cost function determines what is the cost of this particular weight. So if we see over here, the cost is pretty high. So what it tells us is that cost should be minimized so that this y cap and y becomes the same value. So what we do typically over here, we go back and then reapply this weight and again do this calculation and then predict the output value. And this is known as back propagation. We do it multiple times, and after that we finally come to the conclusion that is the final pricing. I understand that neural network is pretty much difficult. It is the very new concept, and I just tried to explain it to you in a very simple term. I'm also not up to mark. If I know neural network in and out, I would be out of Infosys very quickly. So still I'm into the learning phase, but I just wanted to make all of you know what exactly deep learning is all about, how neural network works.
And we are meeting offline after this meet call.
Yes, Bhargava. That was Friday, evening joke. So.
It's being recorded, okay?
Okay. But anyway, guys, this is pretty much what I have got for today's session, and thanks for joining all this session and listening to me. It was really a good learning for me as well.
Yes, and I'd like to thank you very much. Actually, thanks for putting a lot of effort. Actually, your project is pretty busy. Okay, great, sir. Great job.
Yeah, thank you, Bhargava, and thanks everyone.
Yep, agree. Yeah, bye bye.
Thank you, guys.